Okay, so now we're on page 189 and we're going to discuss oil residue. The best way I can describe that is, you ever see when your car gets wet after it's been waxed and you see the beaded water on top of it? Well, that's what happens when oil comes out of refrigerant leaks. Fortunately enough for us as techs, refrigerant and oil are both traveling through the system. And when the oil comes out, the moisture on top of it, water sits on top of it and beads up. You'll see this commonly in evaporator coils and things like that. So your book says spotting refrigerant oil is a good way to find leaks. Oil spots appear usually with a fine coated dust because the dust will adhere to the oil. Now, oils could be present at the Schrader core because you took your hose off. And if you took your hose off, it could have oil there. That doesn't mean it's leaking. Oil blotches from motors and pumps could look like a leak. It could be the result of a previous leak, like the pipes under your cabinet for your sink. You see a stain on the wood or the cabinet and you think it's leaking. It was just a previous leak. Oil may not be at every site. It may be present with micro leaks. And it may reach certain leak positions. And it may not be present at new startups. So a couple pictures in your book. All right, it talks a little bit about that, but I want to go back here for a second. You can see these joints. As your brazing material and solder cools, it cracks. And as it cracks, it creates leaks. Therefore, technically, we can say all joints leak. Now over here, they mentioned microfoam solution. And what is microfoam? Microfoam makes a small cocoon of bubbles. You spray this on a refrigerant, it makes a small cocoon of bubbles where the leak is. So it helps you find the leaks. It may be bigger bubbles if it's a big leak, but there you go. Now what you don't want to do is use soap and Dawn and Dove and all that kind of stuff, because that stuff will actually corrode the copper. Use Big Blue or one of these refrigerant leak detectors that comes readily in the bottle for you for an AC system. Now, testing for evaporator section leaks. What does it say in your book? Page 189. Many leaks go undetected in evaporator coil. This is because the sections are contained in the cabinet and they're closed up. So then it brings you through here telling you how to open up the cabinet, take it apart, and put your leak detector in there. 2 consecutive positive tests. Your leak detector positively detects leaks twice is a leak. 2 consecutive negative tests of not detecting refrigerant, you can rule out the evaporator leak. Remember, refrigerant's heavier than air. When you start looking for a leak, start at the bottom and move your leak detector up. Gravity will cause it to flow to the lowest point of the system. Bubble microfoam solutions, like we just talked about, are very cost effective and successful. They also do not have coagulants and wet adhesives in soap, but your refrigerant bubbles do. So it'll stick to the copper better. This is all on page 190 in the middle. You're following along with me. And soap contains chlorides that corrode brass and iron. Okay, so we read about all that. Now, here you go. Condensing unit leaks. Condensing unit leaks. They want you to calibrate it, take the unit, put a tarp over it so the air outside can't blow the refrigerant around. All right, monitor the leak for 10 minutes until a leak is sensed and look for it. This picture right here, they show the guy with the tarp over the unit in your book. You can see that in clarity right there. That's to stop the air from blowing the refrigerant around while you're trying to detect it. Now, one thing I don't like is putting a lot of joints in the system. I just showed you that the joints leak. So when you put a lot of elbows in a refrigerant system, it's a lot of leaks. So I always like to use tubing benders and have less leaks in the system. Now, advanced leak detection on 191 says this: testing for pressure-dependent leaks. Pressurize the low system 150, the high side to 450 with nitrogen. All right. The equipment plate usually tells you the maximum pressure you can use for that part of the system. If you can't split up the high and low side, pressurize the entire system to what the lowest test pressure is for the system. Okay, so if it's 250, that's all you're going to do. 350, that's all you can do unless you isolate the condensing unit. You think it's in the condensing unit. Now, this is very important. Never use pure oxygen in the system to look for a leak. Let's say you don't have any nitrogen, you out, so you go grab your green oxygen tank. That is a no-no. We do not do that. Well, why? Pure air contains 20% oxygen. Pure oxygen is not pure air. Pure oxygen and oxygen in the air combined with the refrigerant oil, and it can form an explosive mixture. Pure oxygen and oxygen in the air will oxidize rapidly. In a closed system, the oil can help build up this rapidly and may generate pressures to the point that it explodes. So you do not add oxygen to a system to look for a leak. You use dry nitrogen. And you don't use Freon, filling it up with Freon. Okay? Because then you knowingly have to vent it out to the atmosphere. Next on 191, it says testing for temperature leaks. Metals like copper, brass, and aluminum can warp when heated, then contract and seal. So you may have to run the system and get it in a position where it heats up again. Vibration dependent leak, again, you should look for bolts and gaskets, suction line connections, things like that. Like I said before, distributor lines like to touch and rub over time, things like that. One thing I always told you is accumulators. Accumulators are made of steel. They love to put them in a unit when it's close to the bottom of the unit. Well, the homeowner doesn't clean it out all the time. It's got dirt, it's got moisture, it's got leaves, and it corrodes the bottom of the accumulator. If you got a system leaking and you can't find it, you may want to look at the bottom of the accumulator, okay? Try not to make you dizzy right here. But you may want to look at the bottom of the accumulator right here, all right, to find that leak underneath there. You'll have to put your sniffer under there, your leak detector, whatever you want to call it. I used to call mine a hound dog. That baby could sniff, you hear? Now, your book right here shows you a couple of really good pictures of, they put the soap bubbles on there, and you can see right here on this evaporator, there's a leak. And here's a big leak. See that? Now, testing for cumulative leaks, it says installation and personnel must learn good field piping and assembly practices to ensure the system will run efficiently. Many field installed systems last for 50 or more years with good practice. Wow. How would you like somebody to put a system in your house that's going to last 50 or more years? Okay. Now, standing pressure test. Okay. How do you do a standing pressure test? This is probably the most frequently used of all leak detection. Okay. There are several different kinds. The first is the trace amount. This is the trace amount. Okay. Most technicians start with 0 and introduce a trace amount of refrigerant. The same refrigerant that comes with the system. If it's 410A, that's what you use. Just a trace amount up to about 10 psi-G. That's it. The trace gas should be the same as you use in the system. Using the system's refrigerant with a trace gas also avoids any refrigerant and oil incompatibility. Now, you put in nitrogen, you introduce nitrogen behind the refrigerant into the system, and get it up pressurized to the pressure you want. That will help your leak detector. Remember, your leak detector is not there to detect nitrogen. You pressurize a system with nitrogen to look for bubble leaks. You put refrigerant in it to look for a refrigerant leak detector. A refrigerant leak detector does just that, right? It detects leaks of refrigerant, not nitrogen. Now look what your book says next. You know you can't run the system with nitrogen and a trace amount of refrigerant. You have to release that to the atmosphere. And it says right here, the trace gas should enter the system in the middle hose and be put in there. The EPA, the Environmental Protection Agency, because there must be some refrigerant in the system to leak detected, says this is acceptable. Only because you're trying to stop the system from leaking. They'll accept this. When the trace gas is done, then you put in the nitrogen, the low pressure side, usually around 150. All right, the pressure used to pressurize a complete system must not exceed the lowest test pressure of the system. So you go look at the label on the evaporator coil and it says 250. The system pressure should not exceed that. Don't go over that. Okay? And then let's see what else it says here. Okay, so in a minute, on our next video, we'll get into page 194 and talk about leak detection methods. Okay?